Okay, so this is the last question then. This is 2023 Higher Level Maths Leaving Cert Paper 2, question 10. Seamus has a basin in the shape of an inverted right circular cone with the lower part removed as shown in the diagram on the right below. Diagrams are not to scale. The radius of the original cone is 15 centimeters and C, the slant height of the basin, is 10 centimeters. The base of the basin is a horizontal circle with a radius of 12 centimeters as shown. The basin is open and does not have a top. Show that BE is equal to 40. So this distance down along here is 40. So the way I'm going to do this is to have a look at this right angle triangle here and this right angle triangle here, and just look at similar triangles. So we have a right angle triangle like this, and we have another one here. So that's right angle, that's right angle. So these two are parallel. So this is 15 centimeters, this is 12 centimeters, this is 10 centimeters here, and this is, I'm going to call this X here. This is B, D, A, C, and we have E over here. So this is one of your theorems, so you can just say that we have two similar triangles here if you like, so sides are in proportion in order. So what I'm going to do is look at the big triangle first and take this 15. So I'm going to take 15. I'm going to put that over the corresponding side of the smaller triangle, which is 12. That's going to be equal to, I've got to go back to the large triangle again, so I'm going to look at this side here. So that's 10 plus X. I've got to put that over the corresponding side of the smaller triangle, which is X. So now I have an equation here, just X in it, so I can just solve for X. So what I'm going to do is cross multiply, so you get 15X is equal to 120 plus 12X. Bring the 12X over, that gives 3X is 120, and then finally we get an X equal to 40 centimeters. So that's equal to the distance BE. Okay, so that's part one, easy enough. Find the total internal surface area of the basin correct to one decimal place, the total internal surface area. So the way I'm going to do this is I'm going to have a look at finding the surface area, the curved surface area of the big cone, the curved surface area of the small cone. I'm going to subtract them, and then I'm going to add this circle here as well, which is part of the internal surface area of the basin. So let's write all that out. So the internal surface area is going to be equal to pi r L of the large cone plus pi or L of the small cone. Actually, it's going to be minus pi or L of the small cone. So that's our curved surface areas. And then I want to add the circle, which is just going to be pi r squared. So let's stick in the numbers. So we've got pi, we've got the radius of the large cone, which is 15. And we've got the length, the slant height, if you like, of the large cone, which is 50. We're going to subtract pi times the radius of the small cone is 12, and the slant height is 40. And then we're going to add the circle, then the base of the basin. So that's going to be pi times r squared, and that's going to be 12 squared. So all of that is just calculator work. So I've done all of that. So it's 1300.6 centimeters squared. And this is to one decimal place. Now there is another way of doing this. I'll just quickly run through it. There is a formula in your tables for the frustum of a cone, so I'm going to use that. That will give you the curved surface area only. So we'll do the internal surface area again. Okay, so it's going to be equal to the frustum's curved surface area, which is pi times r, which is the small radius, plus or, which is the large radius, times L. And then we've got to add the circle again, which is pi r squared. So it's going to be pi times 12 plus 15 times L, in this case, is going to be 10. And then we've got pi times the radius again, so it's just going to be the same up here. So it's going to be pi times 12 squared. When you do all of that, you get the same answer. You get 1300.6 centimeters squared. Now that formula isn't actually on the course, but it's in the tables, so I'm not sure if they'll accept that or not, but there's no reason why they shouldn't really, I guess. Let's move on to part 3. Draw a diagram of the net of the curved surface area of the basin. Show your working out. Include on your diagram enough measurements of lengths and or angles so that the net could be constructed using a ruler, a straight edge, a compass and a protractor without any further calculations. Your diagram may need to include lines that are not part of the net itself, like the broken lines in the diagram on the previous page. Okay, so we have to just imagine that the entire cone is opened out. So that's going to look something like this. And then we're going to have two curves here. One here like this and one here like this. And we need, so we're not going to include, we just need the curve, we just need the net of the basin. So this is the part we need. We don't need this bit down here. So this is kind of the dotted line, if you like, that they were talking about. So this is not part of the basin itself, but it just aids in the construction. Now we know that this here is going to be 10 centimeters out here. And we know, we've got to work out this distance and this distance here. So these two curves here are going to represent this circle here and this circle here. So we need to find the circumference of this circle and the circumference of this circle here. So the circumference of a circle is 2 pi r. So the circumference of the large, if you like, the large circle is just going to be 2 times pi times, that was 15, so that's just 30 pi centimeters. So this distance along here is going to be 30 pi centimeters. The circumference of the small circle, if you like, is going to be 2 times pi times 12. So that's just 24 pi centimeters. So here is going to be 24 pi centimeters. Now the last thing we're going to calculate here is the angle, this angle here. Now the way I'm going to do that is, I know that that's 10 centimeters there, and this is 40 centimeters down along here. So I'm going to use again the formula in your tables. So L is equal to R times theta. So theta is just going to be equal to L over R. So that gives us theta here is equal to L, which is this distance here, which is 30 pi, over the radius of this circle here, if you like. If this was a complete circle around here, the radius would be 50. So that means our angle here is just 3 over 5 pi. So this angle here is 3 over 5 pi, and that's it. So I think that's about enough information. With that information, you should be able to draw this this net of the basin, the curved surface area of the basin. So let's move on to the next question. Seamus needs to pick a new PIN code. So this is a completely different question. It must be a 4-digit code. It must use exactly 4 of the digits from 1 to 9 so that no digit can be used more than once. Work out how many such codes are possible. So the way we normally do these is we do these 4 boxes here. I'm going to multiply these numbers. So how many possible choices do we have for the first number? That's going to be 9. Now once we've chosen a number, then we only have 8 left. Once we've chosen these two numbers, we've only got 7 left to choose from, and then we've only got 6 left to choose from. So when you multiply 9 by 8 by 7 by 6, you get 3024. Work out how many of these codes contain the digit 2. So if you imagine you've got a 4-digit code, and in there, let's say the first number has to be a 2. So if the first number is 2, that means you've only got one choice. So if you've chosen a 2, you've only got 8 left to choose from, then you've got 7 left to choose from, then you've got 6 left to choose from. So if you multiply those 3 together, those 4 together, actually you get 336. However, the 2 that we put here at the start could be there, it could be there, it could be there, or it could be there. So there are 4 possible places that we could put the 2. So in other words, we take the 336 and we multiply that by 4, and that gives us 1, 3, 4, 4. So work out how many of the codes in part B1 have the sum of their first 3 digits equal to their 4th digit. The codes can contain the digit 2, although they don't have to. So let's have a look at the lowest number that we can have out at the end, and that's actually going to be 6. So if you have any other number, let's say lower than 6, so let's say 5, there aren't 3 different numbers anyway that will add to give you 5. The 3 lowest numbers are 1, 2, and 3, and they add to give you 6. So we're going to have to start with 6. Now the possible numbers that will add to give you 6 are 1 plus 2 plus 3. There aren't another 3 numbers that we can put together to give 6. So how many ways are there of arranging these 3 here? It's going to be 3 factorial, which is just 6. So let's have a look at the next number up. The next number up is 7. So how many ways can we make 7? Well, if we start with 1, add 2, that means we'll have to add 4. There aren't any other numbers. If we start with 2, for example, and add 3, that'll give us 5. And then we'll need another 2 to give us 7, which means we'll be repeating the 2, so that's not going to work. So really the only way we can do this is 1 plus 2 plus 4. So again, this is 3 factorial, which is 6. So we have 12 combinations so far. Let's have a look at the next number up, which is 8. So with 8 you can do, let's start with the lowest, 1 plus 2, we would need a 5. And we can also use, let's see, we can use 1 plus 3 plus 4 to give us 8. So I think these are the only combinations. So here we've got 3 factorial again, which is 6, and another 3 factorial here, which is 6. So again, you know, if you try 3 here, well, you'll have to add a 1 and a 4. The only combinations, if you choose 4, you'll have to add a 1 and a 3. So there's no other combination of digits that we can use here to give us 8. Okay, so we have 4 lots of 6s so far. Let's have a look at the last one then, 9. So how can we form 9? Well, we can form 9 by adding 1 plus 2 plus 6. We can form 9 by combining, let's say, 1 plus 3, which will mean we have to add a 5 here. And let's see, do we have another one? If we take 1 plus 4, that means we would have to add another 4. So that's not going to work. If we take 5, 6, 7, 8, 9, we've already done that one. If we take 6, that will mean we have to add a 2. So we've already done that one up here. So we've done all the ones, if you like. So let's start with a 2 here. 2 plus 1 we've already done. 2 plus 3 we haven't done. So let's try 3. That'll give us 5, 6, 7, 8, 9. So we need to add 4 here. So that's it, 2, 3, and 4. And there aren't any other combination of numbers. So here we've 3 lots. So this is going to be 3 factorial, 3 factorial, 3 factorial, 6, 6, 6. 1, 2, 3, 4, 5, 6, 7. So our answer then really is going to be 6 times 7, which is 42. So there are 42 codes who have the sum of their first 3 digits equal to the 4th digit. So that's it there. And that's it for this question and this paper and this exam.